Hey guys, happy Friday. Mrs. Hedrick here. We're working, this is Math 8, April 24th, Lesson 20. We're going to be doing the guided practice and the independent practice, okay? I have a pencil, a ruler. I used my parchment paper, right, as my tracing paper, or you could have a really thin piece of like copy paper, Xerox paper, and I got a calculator if I need it. All right, my friends, we are going to be working in our instruction book on page 180. Let's start there. Okay, good news and bad news. Good news is I'm not going to do the last problem on the page, on the set. Bad news is the quiz will be Monday. So I'm going to try something different. I'm going to post a video of me going over the quiz just to see if that's helpful to people. Okay, so we'll see how that goes. All right, my friends, let's go ahead and take a look at number 8. My phone was dying, so I had to go get a charger and start my video over. So I already started number 8, but we'll get through it. Okay, let's read it. So pretend that's not there yet. The coordinates of the vertices of triangle OPQ are O, 0, 0, P, 4, 0, and Q, 2, negative 4. Triangle OPQ is dilated with a center of 0 and a scale factor of 3/2. Sketch the dilation. What quadrant or quadrants contain the image of triangle OPQ? All right, so what I was starting to do, and then my phone died, all I did was write out triangle OPQ. I copied these. So O is 0, 0, P is 4, 0, and Q is 2, 4. And then I plotted them. And then now this is the original triangle. Okay? All right, and I could draw, and I'll just draw it anyways, even though it's on the axis, it's kind of hard to see. All right, my friends, now, I have a scale factor of 3/2. So remember what we do with the scale factor. We're going to multiply all of these numbers by 3/2. Times 3/2, times 3/2, times 3/2, 3 over 2. Now, you probably don't have the handy dandy calculator like I do, right, that I can type in 3 over 2. So we did this on another problem. What is 3 over 2 equal to? So if you take your calculator, you could turn your calculator on and type in 3 divided by 2, and you should get 1.5. So it's okay if you multiply by 1.5. Okay, so grab your calculator, and we're going to come up with the new coordinates after this dilation. All right, so this one's easy. 0 times 1.5 and 0 times 1.5 is 0, 0. If you remember earlier, we highlighted our notes saying that when the number doesn't change, or what did it say? It transforms into itself. That means that this is the center. And they already told me that the center was 0, 0. So this point does not change. All right, let's do this one. 4 times 1.5, or 4 times 3/2, 4 times 1.5, I have 6. And then this is easy, 0 times 1.5 is 0. So the new point for, it'd be like P prime, would be 6, 0, over 6, up and down 0. So that's my new P prime, I guess. Okay, let's do the next one. I'm going to clear it off. 2 times 1.5. I think I can figure that one out. It's 3. And then negative 4 times 1.5. That's negative 6. All right, so just to be clear, I took every single number, and one at a time I multiplied them by 3/2, or 1.5. And these are my new coordinates. So I did 0, 0, 6, 0. Now I have 3, negative 6. So over 3, 1, 2, 3, down 6. So this is now the new triangle. Now I kind of off a little bit. Sorry. We'll use our wonderful imaginations that I drew that perfect. All right. I can see it. You see it? Not bad. Okay. So we just sketched, we sketched the original, and then we sketched the dilation. Because this is greater than 1, the shape got larger. Should we write that somewhere? Just some notes. Can I put it up here? So if we look at a dilation, if the scale, if I can spell, the scale factor is less than 1, it's going to get smaller, shrink. If the scale factor is equal to 1, it stays the same. We don't really multiply by a scale factor of 1. If it's greater than 1, it gets larger. And then do you remember, if we have a scale factor, those create similar shapes. They're not the same size, like these aren't the same size anymore, so they're not congruent, but they are similar because the ratios would be equivalent. So the ratio of this side to this side would be the same as the ratio of this side to that side, the ratio of this side to this side. Okay. The only question on this one is, what quadrant or quadrants contain the image? Well, they're all down here. Do you remember how we number these? This is quadrant 1. Remember, it's 1, 2, 3, 4. Do you remember which direction it goes? Counterclockwise. 1, 2, 3, and they use Roman numerals. Quadrant 4. So we could say the image is in quadrant 4. I'll write it in regular numbers. Okay. All right, not too bad. All right, next page. Okay, this one is so easy. Oh my gosh. And it looks like it should be terribly, terribly difficult. The coordinates of the vertices of a trapezoid are 0, 0, 2, 4, 5, 4, and 7, 0, right? You remember a trapezoid is like a triangle that you cut the top off. Sometimes it looks like a boot, right? Okay, those are my trapezoids. Okay. The trapezoid is dilated with a scale factor of 2. So if a scale factor is 2, that's greater than 1. So this is going to get larger. The center is still 0, 0. So that means when we multiply, those numbers don't change. What are the coordinates of the vertices of the image of the trapezoid? Okay, guys, this is so easy. I'm going to make a list of the old coordinates. I'm just copying. No new math here. Copying, copy, copy, copy. They didn't even give me points. They didn't say A, B, C, D, none of that. Okay. Scale factor of 2. Multiply every single number times 2. That's it. That's all there is. Okay, this is easy. 0 times 2, 0. 0 times 2, 0. So there you go, guys. There's the center, right? It transforms into itself. They already told us that. 2 times 2 is 4. 4 times 2 is 8. 5 times 2 is 10. 4 times 2 is 8. 7 times 2 is 14. 0 times 2 is 0. That is your answer. That's it. Is that easy? I don't know. Let me look and see if you have one of those on your quiz. Of course, you don't have one that easy, but you will. You might need to multiply scale by a scale factor. So at least we practiced. Okay, you do have these kind on the quiz. So it says, what 2 transformations could transform the smaller square to the larger square? Okay, so I think there's 1 or 2 questions on your quiz where it says, how did they get from this shape to that shape? Like you have to try and figure that out. Okay. Okay, first of all, the original square is small, and then this square is larger. So what transformation is that? Is that a translate, a reflection, a rotation, or a dilation? Well, when they change sizes, we know that we have a dilation here. And because it got bigger, I know that the dilation has a scale factor greater than 1 because it got bigger. That's all. And those notes I wrote on the other page. Now, the orientation has changed. Did you notice that? So, like, the point of this square is now over here. So I need to turn my triangle. So what's a turn? I'm going to need a rotation. Okay, now I'm going down, let's look at the answer choices here. Can I get rid of anything? Dilation, 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 dilation. Okay. We all agree. And then rotation, 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 rotation. Okay. All right, now look at scale factors. This says scale factor of 3, scale factor of 3, scale factor of 1/3, scale factor of 1/3. Mine got bigger. So I know that C and D are no good. The shape didn't get smaller, it got bigger. So these aren't correct. The other thing to remember, you can write this note to yourself too, that the scale factor is the new shape over, should use old, but I've been using original. Okay, so let's try to figure out this scale factor. Okay, look at the new square. So I went transformations to transform small to large. So the new square is the large square. What's one side of the large square? You see it? It's 6. What is one side of the old square, the original square? It's a 2. What is 6/2? What's that? What if I simplify that, what would that equal? So we have a scale factor of 3. And if you look, scale factor 3, scale factor 3. Okay. The only other thing we have to figure out is, did they rotate at 45 degrees or did they rotate at 90 degrees? Okay, so that's where I had you grab your little tracing paper. Okay, so I'm going to try something. Some of you might be able to figure this out without doing all this drawing, but I just want to try to explain it a little more clearly. So here's these are my axes. And then I'm going to lightly trace my square. Okay, it's not perfect, but you know, you get the idea. We're going to put our pencil point on the origin, right? Didn't they say they rotated about the origin? Yeah. So am I going to rotate this 45 degrees about the origin or 90 degrees? All right, let's try it. I just need it to line up. It's not obvious, it's not going to be the same size because I haven't dilated it yet. Okay. If I turn it, look at the axis. Do you see that? My axis is here. This is a 45-degree rotation. Can you see my pencil square? Is that the same shape? It looks like it. Look at what 90 degrees would do. 90 degrees puts it back where it was. Okay, so it's not 90 degrees, so the answer has to be A. Hattie chose C. Oh, what did Hattie do? Oh, Hattie had it backwards. She went, look, she had that right, but she had the scale factor wrong. So I'm just going to say Hattie had the scale factor backwards. She must have thought that was the new shape and that was the old shape. Okay. All right, not bad. All right, let's turn the page. Okay, here's another one that's not very hard. And I'd love to say that there were a ton of these on your quiz, but that would be a lie. I'm sorry. An equilateral triangle with a side length of 1.5 is dilated with a scale factor of 4. What is the length of one side of the image of the triangle? Okay, so if you remember, equilateral triangle, oh, I don't know if I can draw one. All sides are the same, pretend. And they're saying that this is 1.5. And remember we talked about these are going to be similar shapes. And because this has a scale factor of 4, this is going to get larger. So if I would multiply all the vertices by 4, all I'm going to do is multiply that side by 4. That's right, my friends. It's that easy. So if you grab your calculator and you type in your 1.5 times 4, the new length, the side on the new triangle is going to be 6. Easy enough. Okay, for the life of me, I've tried to figure out why they have all those circles on this problem, and I don't know. I have no idea. Let's read it. Triangle ABC is shown in the coordinate plane. There it is. Shade in the points that represent the vertices of triangle A prime, B prime, C prime after dilation using a scale factor of 2 with the center of dilation at the origin. Then connect the vertices A prime, B prime, C prime to form the new triangle. Okay, So I thought I had to shade in these little circles. But guess what? None of them match the new triangle, I don't think. So I really, there's not one of these on the quiz. However, the dilation is good. Let's practice that. Okay. First thing I'm going to do is I'm going to write down A, B, and C. So what are the coordinates of A? -1, 1. Right? Back 1, 1. Okay. B is 1, 3. And C is, what is that? 3, 2. Now you remember, scale factor of 2, I'm going to multiply every single digit by a 2. All right, now remember when it changes, sometimes we refer to it as A prime. That just means this was the original, this is the new image, okay? So just multiplying by 2. What's -1 times 2? -2. What's 1 times 2? 2. The new image, B prime, would be what's 1 times 2? 2. 3 times 2? 6. And C prime, 3 times 2? 6. 2 times 2? 4. So I expected these little dots to be on these locations, and I don't think any of them are. So, okay, that's all right. Let's try it. All right, I'm going to do A prime. So start at the origin, -2, +2. That is A prime. Go back to the origin, +2, +6, way up here. That's B prime. And then C prime is 6, 4. So start here, out to 6, up to 4. See, they don't match. I don't know, guys. And I'm looking at the answer key, so I did it the right way. I don't know why they have those there. Maybe it was a mistake that they never fixed. Okay. Use my straight edge. Let's connect these. Okay. There you go. Done. We've got A, B, C, and now we have A prime, B prime, C prime. We connected them. There's our new triangle. We got this. That's okay. Okay. All right, let's try number 3. On the coordinate plane below, triangle ABC is rotated 180 degrees around the origin and then dilated by a scale factor of 2. The center of dilation at the origin to form the blue triangle, where X, Y, and Z represent the side lengths of the triangle. Okay, so I'm going to take this little guy here. I'm going to trace him so we can see it. I'm going to rotate him 180 degrees, right? 90, 180. And then once we get it down here, we would dilate it by a scale factor of 2. But we don't really need to do that because all they want us to do is to complete the proportion below by entering either X, Y, or Z in the appropriate denominator. Remember, so we're going to say segment A. Some of you might be able to do this now, so go ahead without tracing. AB matches which side over here? Does it match Z, Y, or X? I think I can figure this one out. Look, AC, that's the longest side. AC matches which one of these is the longest? AC goes with X. I know that. Okay, go ahead and finish it. I'm going to trace it real quick. I'm just going to recycle my paper, right? So I'm going to trace the origin or the axes real quick. That's very helpful. Very helpful. Okay, Mr. Hedrick is down there cooking dinner. That's right, kids. Mr. Hedrick's cooking dinner. And he's using a food chopper. And it's so loud. I don't know if you can hear it. I don't know if you can hear it. Okay. All right. I'm just happy he's cooking dinner. Go, Mr. Hedrick. Okay. I'm trying to be neat and tidy here. But I'm having a heck of a time. Okay, I'm just going to eyeball it. Don't tell. This is C, this is B, and this is A. All I want to do is rotate this 180 degrees around the origin. Remember, it doesn't have to be clockwise or counterclockwise. Remember from the video? Because it'll end up in the same place. Okay, you ready? Watch the axes. When I line them up, there's 90. There's 180. Okay, so now this is much easier to compare. Can you see? AC matches X. This is BA. What is it on my paper? AB. AB matches this side. What is it? Can you see it through my paper? Y. AB goes with Y. So that better be BC matches Z, and it does. Okay? Not bad. Okay, one more problem. We got this. We got this. I'm going to skip this last one. It is not on the quiz, and we're all tired. It's Friday. Okay. All right, my sweet children, last one. Okay. Describe at least 2 different transformations or sequences of transformation that would transform square A to B. This is important. Big square to little square, okay? There's a couple of these on the quiz. So you have to be able to describe, how did I go from here to here? So what's your first thought? Well, what could we do? How do I go from A to B? Okay, please tell me you see that this is getting smaller, right? These are not congruent. These are not the same. They're similar, but they're not the same. So there has to be a dilation, no matter what. Could I dilate before I did other things? Sure. So let's say I did a dilation. What would my scale factor be? Okay, let's write that out. So scale factor is new over original. Okay, so I went from A to B. So this is the new. So just pick a side. How long is this side? 1, 2. So I've got a scale factor of, can you see that in the green? I hope you can. 2 over, how long is this side? 4. So 2 over 4 is also the same as what, 1/2? So my scale factor, I can either say is 2/4 or I'm going to use 1/2. Okay. So I'm going to have a dilation with a scale factor of 1/2. Okay, so I'm going to shrink it. Shrink. Okay, and it'll be this size, right? If I shrink it. How do I get it to here? Well, translate, rotate, reflect. What do you think? Could I slide it? Yeah, I could. I'm not going to write slide. I could dilate it, scale factor of 1/2, and then I could translate it. Okay, do they need to know how many translate? Of course they do. Okay. How far would I be going? Let's pick a point. How hard? What do I need to do to go from, which one's right? This point to this point. What would I do? I would translate down 2 and left 2. Okay, right? To get this, so if I move this whole thing down, and then over 2. All right, give me another one. So this is one example. So this will be example 1. Let's do another example. How do I go from here to here? All right, well, let's dilate it again. I have a dilation, that didn't change, with scale factor of, 1/2. Okay, so now don't translate it. Could I reflect it or could I rotate it? Could you see a rotation? Oh, I so see a rotation, right? I'm going to sketch it super quick. I'll just do a quick sketch here. Oh, that was horrible. If I have that and I want to get it down here, 90, 180, right? So I could rotate it 180 degrees, right? Because I could have gone the other way too. I know this is kind of quick drawn, but 90, 180 gets it there too. Okay. Now, you could you reflect this across, like flip it like this way? You could. Did they use that in my book? What did they say? Rotate it. No, they didn't say reflect, but you could. You could reflect it across like this diagonal line. But let's stick with these 2. Okay, I am not going to do this one. It is not on the quiz, and we're tired. Okay, your homework. For practice before our quiz on Monday, I want you to do practice and problem solving, page 215 and 216. Remember, I posted the answers earlier in the week. Please do it. I know you don't want to, but do it. It's good practice, and you'll do well on your quiz. Okay, bye, guys. Have a wonderful weekend. I'll see you Monday.